So today we will continue solving trig equations, and this is what we did in the last lesson where we just had to isolate the trig function, but we'll see things like this today where we'll have to get a common denominator or a factor, do a little more work before we solve. And we only need to find solutions. When it says this, we only need to find solutions between 0 and 2 pi. So when we look at this and we see cosine squared, remember to consider using a Pythagorean identity, sine squared plus cosine squared equals 1. Keep that in mind. And we also see something that could be factored like a quadratic. And the only problem is we have different trig functions, so why don't we change this into a sine, because we can't change this into a cosine. So let's substitute for cosine squared. We know that cosine squared is 1 minus sine squared, so this will be 1 minus sine squared. Distribute. Combine the 2 and the negative 1. And then we can think of it as negative 2u squared minus u plus 1 equals 0. That will look more familiar than having trig functions with a quadratic, and just know that u is equal to sine of x. And if we factor this, we could factor it like this, where negative 2 times 1, we have to add to get negative 1. So we're going to go negative 2 times 1 is negative 2, negative 2 plus 1 is negative 1, and then we would do this. Minus 2u plus 1u, and then plus 1. So we can take out a negative 2u, take out a 1, factor out a u and a 1. So we have negative 2u plus 1, u plus 1, which is negative 2 sine x plus 1, sine x plus 1, and then we just have two equations to solve. Subtract 1 and divide by negative 2, and we'll get a positive 1/2. And here, subtract 1. We want to know where we have the opposite over hypotenuse is positive. The opposite is a 1. Hypotenuse is a 2. And then we can see that that's going to be a 30-degree triangle. Over here we have negative 1. Let's call it, instead of opposite, we'll do y over r. So the y value is negative and the radius is 1, and that puts it down there. It doesn't form a triangle, that's on the axis. So here we have 3 pi over 2, and over here we have pi over 6 and 5 pi over 6. Okay, similar problem, so pause the video and try that one. I'm going to move everything to the right. And let's replace sine squared with cosine, 1 minus cosine squared, because we know with the Pythagorean identity we have that, which we want to replace sine squared. So let's solve for sine squared. 1 minus cosine squared. That will be 1 minus cosine squared. Combine the 2 and the negative 1, and it's negative 2 cosine squared plus cosine plus 1. We'll factor it. We can factor it like we did the other one. You can write it like this. And if you factor, we have to have a plus 1, plus 1. And that all equals, these multiply to get 0, so we know that each of them could be 0. And there'll be a negative divided by a negative is a positive. And here we have x over r, and this is x over r. So the x is positive, that means the triangle, the angles will be over there. X value of 1 and a radius of 2 with a y value of radical 3. So that means it's a pi over 3, and over here we have x is negative, so it's going to be over there, and that gives us pi, and this is going to be pi over 3 and all the way around to 5 pi over 3. And let's need to make a correction here. That's going to be negative 2, positive 1. So we need to do this. This has to be the negative, and that's the positive. That means this is the positive, and this will be negative. Over here we have a negative there, and that'll be a positive. So the angle is going to be there instead of there, and we'll get 0 and 2 pi. Here we have a negative, so it's not going to be that. It'll be on the other side, and we're going to have 2 pi over 3, 2 pi over 3, and 4 pi over 3. Here we'll have to get a common denominator first, so let's look at cosecant will be 1 over sine, and cotangent is cosine over sine. So we could get a common denominator. I did it a different way, and I guess I'll do it both ways. So if we get a common denominator, we'd have 1 over sine, and here we'd have cosine over sine. So 1 minus cosine over sine, and looks like we will have to, we could do this, 1 minus cosine equals sine, negative sine. We're going to, no, positive, multiply both sides by sine, and let's go ahead and square both sides, because we can't solve anything unless it's factored, and we can't factor anything here. But if we square it, we'll have a Pythagorean, we can use Pythagorean identities, so let's square it. So don't forget to distribute this, and we're going to end up with that middle term. And now this is going to be like one of the previous problems. Let's put everything on the left side, and we'll change that into a 1 minus cosine squared. So we have cosine squared minus 2 cosine plus 1 minus sine squared sine squared is 1 minus cosine squared. And now we have so we're going to have 2 cosine squared minus 2 cosine. That'll be a 0. So now we can factor out 2 cosine. So we have 2 cosine times cosine is 2 cosine squared. 2 cosine times negative 1 is negative 2 cosine. And then we can say that that equals 0, or that equals 0. And that's x over r. X is positive right there. And when cosine is 0, that's x over r, which would put us there and there. So we have x equals pi over 2, 3 pi over 2, and over here we have x equals 0 or 2 pi. But we have to be careful. Let's see which one, some of them may be extraneous. So let's look at pi over 2. If you put pi over 2 for sine, that's defined, and that's going to be 1, 0, so we get 1 minus 0. Pi over 2 works. If you put a 3 pi over 2 here, you get a negative, and that's going to work there. But sine of 0 is 0, so when we check these solutions, if you put a 0 in for sine, it's going to be 0, and sine of 2 pi is 0. So that's going to give us division by 0, and they'll be undefined. So these are extraneous. Now let's check the 3 pi over 2 again. If you put a 3 pi over 2 here, you get a, when x equals 3 pi over 2, you have 1 over sine 3 pi over 2. And this is going to be extraneous also because sine of 3 pi over 2 is negative 1. That's 0 over negative 1. So we have negative 1 equals 1. And that means that these are extraneous. And the only solution is pi over 2. Oh, and on the previous problem, I think that's the best way to do it. I said I'd do it 2 different ways, but I think that way is the most obvious way. Okay, so there's a similar problem. Pause the video and try that one. And it's already looking like a Pythagorean identity, but we would like to have tan squared plus 1. Let's get secant by itself. And maybe you solved it a different way. Here's another way to do it. And we want everything with tangents, so let's change the secant squared into a 1 plus tan squared. And we're going to go subtract 1, so there's no more 1. We're going to subtract tan squared, and we end up with just divide by negative 2, and we want to know when tangent equals 0. Tangent is y over x. So we want a y value of 0 with an x of 1 or negative 1, so that puts us here. And we get x equals 0, 0, or pi. And then let's check these values. 0. This is 1 over cosine. Cosine of 0 is 1. So we would have, if we're checking, let's check with this. 1 over cosine x plus 1 equals sine over cosine. So let's check 0. Put a 0 there, and we get 1 over 1 plus 1 equals sine of 0 is 0. Cosine of 0 is 1. So we get 2 equals 0. That means 0 is extraneous. And if you put pi in there, it's going to be a solution. It'll work. So we know that that is extraneous. And there's a similar problem, so pause the video and try that one. We need to get these squared so that we can use the Pythagorean identity. And since we can't change the sine into a cosine, we have to change the cosine into a sine. Add sine. Add sine. We're going to get 2 sine squared. I'm going to subtract 1, so that's gone. Take out 2 sine x. We're left with sine x minus 1. Add 1. Divide by 2. And we want y over r. Y is 0. That happens right here or there. Here we have y is 1, r is 1, so that happens there. And then we'll check. We have x equals 0 or pi. Here we have pi over 2. So we have cosine x equals sine x minus 1. And if we check 0, we're going to have cosine of 0 is 1, sine of 0, so that is extraneous. 1 does not equal negative 1. And let's try pi. Cosine of pi equals sine of pi minus 1. So that's going to be a negative 1 equals 0 minus 1. So that's a solution. Pi is a solution. And let's try pi over 2. Cosine of pi over 2 is 0. Sine of pi over 2 is 1. And that's a solution. So we get pi and pi over 2 are solutions. Alright, so let's work on combining these, and pause the video, try that one, and work on getting a common denominator. So let's work on the tangent separately from the secant. We have 1 over secant, and we'll go with everything in terms of sine and cosine. Tangent squared would be sine squared over cosine squared. This 1 over secant is cosine. And let's get a common denominator. We need to get a common denominator here, and go ahead and reduce that. We will multiply by cosine over cosine. So now we'll have a common denominator, and we have sine squared plus cosine squared. So that equals 1 over cosine, and 1 over cosine is secant. secant is r over x. Radius of 2 with an x value of 1, so that occurs over here. 2, 1, and that must be a radical 3, so that gives us pi over 3 and 5 pi over 3. And then we'll check that. So let's check pi over 3 and 5 pi over 3. And we can just use this graph here for tangent. So in tangent, for pi over 3 will be a radical 3 over 1 squared, so that'll be a 3. Secant of pi over 3 will be 2 over 1. Cosine will be 1 over 2, and that equals 2. So that's a solution. Let's try this one with tangent. Here will be negative radical 3 over 1 squared is still 3. Secant is still 2. Cosine is still a half. And so that works. So they're both solutions. No extraneous solution. Solve that on 0 to 2 pi. And if you have two fractions, and this is looking more complicated, but go ahead and just try